Good morning, kids, and welcome to physics class. We're your teachers. I'm Kari.
And I'm Janka.
And we're here to teach you about the greatest subject in science, physics. All right. So we're going to start off today with a problem about Eric. Now, Eric is a nice young boy, and he is
This is Eric.
Hello.
No, let's get the end. Eric is running off this cliff at 4 meters per second. But below, 10 meters below the cliff, is a pile of glass shards, 7 meters long. So today, Janka and I are going to teach you how to find out if Eric running at this velocity will allow him to land further than the glass shards and not get injured.
Or killed.
Yes. So Janka, do you want to show us how we can start off this projectile motion problem?
The equation we'll use is velocity, never mind,
We're going to use a position function.
x
Smart
final
idea.
equals x initial plus velocity initial plus 1/2
You're missing something.
acceleration. It's there.
And we're going to add time right there, too.
There we go.
Yeah.
Okay, so,
This is an
Hold on,
equation.
guys. I have a question.
yes,
Is this the vertical direction or the horizontal
great
direction?
question. So, this equation can be used for vertical and horizontal, and what we're going to use it first for, we're going to use it for the y direction. And I'll tell you why in a second.
Why?
All right, we're going to use this function for the vertical direction first because it's going to help us find the time it takes for Eric to start at the cliff and fall to the bottom
In
because
free
of,
fall.
yes, because of gravity.
Kari, do you want me to give you the values?
That'd be great.
All right. So what's the initial distance?
Well, 10 meters, and he'll go to 0.
So initially is at 10. We go to 0. What's the initial y velocity?
Y velocity will be 0 because he's only
Why?
moving in the x direction.
Wow.
And what's the acceleration?
Well, he's going negative 9.81 meters per second.
That's a strange number. How do you get that?
Second squared, meters per second squared. 9.81 meters per second squared is the gravitational constant on Earth.
You should have that memorized. All right. Now Sister Mom will say we're going to do some voodoo math.
We're not doing calculus, guys. What?
Don't worry, kids. Just don't try this at home.
All right, and now we solve for t.
Do you guys know what the answer for t is yet? Well, let's pull out our calculators to find out.
Yay.
Duncan, I recommend you use a TI-84, and that can be a silver edition or a regular. So what we're going to do negative 10 times 2 divided by negative 9.81. And that will give you t squared. So t squared is 2.039. But we want to find the square root of that so we can just find time. And that would be 1.43 seconds. Great job. So you guys already have half of the problem done. Now,
Wait a minute. What does that time mean?
Oh, good question. Great question. This time means that it takes 1.43 seconds for Eric to start at the top of the cliff and land at the bottom.
So are you saying that the initial velocity does not affect the time?
No, because in the y direction, he's in free fall. And objects in free fall don't have a y velocity.
So the initial horizontal velocity does not
Don't have an initial velocity.
does not affect how long it takes him to fall to the ground.
Does that make sense, class?
Great, I'm glad it does. Now we're going to find out how far Eric will go in the horizontal direction. And we're actually going to use the same equation for this problem. So Janka, do you want to write the problem out, or the equation out again?
Yeah.
All right, and I'm going to write x direction above it. That way we know which direction we're always going. And this is important, kids. to remember because velocity, you see it's a vector and not a scalar, so it has a magnitude and a direction. All right, so what we're going to do, we're going to plug in some numbers and we're going to find how far Eric goes, and we'll see if he gets past the glass shards or if he lands a very painful landing. So, do we know what the initial x would be?
0.
Great. Now, you might get confused. You might think that the final x value would be 7, but that's actually not right. This is just how far the glass goes, but we don't know how far Eric will go.
Once we find how far Eric goes, we'll compare that to the 7 meters in the problem.
Okay, so we'll leave x final as x final. All right, so let's find the initial velocity. So the initial velocity in the x direction is indicated right here by 4 meters per second to the right, or in the positive x direction. All right, and the time, we actually found the time in this formula because the time is the same since it's not affected by the horizontal velocity.
So that's why we solve for the time.
Perfect.
And we're going to just cross this part out because in the x direction, there's no acceleration.
Yep, there's no acceleration because there would be no free fall in the x direction positively, and his horizontal velocity is going to be constant the whole time he goes down. So we're going to go ahead and plug this into our calculator to find out what the final. So we're going to do 4 times 1.43, and we get to 5.72 meters.
So class, let's compare that to 7 meters. Does he make it or not?
Well, it looks like from our calculation, Eric is going to land in the glass. It's going to be about right here. So
Poor Eric.
all right, that guys, thanks for listening. We hope you learned a lot about projectile motion today.
Oh no.
Eric died.
It looks like he fell into the glass shards.
That's physics.